The socket is the electrical interface between the CPU and the motherboard. It attaches directly to the motherboard and houses the CPU. The socket is either made of plastic or metal, and it uses metal contacts for connectivity to each of the pins or the LANs of your CPU. This particular socket that we're showing here is an LGA 2011. And this is a common socket used by Intel for Core i7 and Xeon CPUs. Now, historically, the socket has been considered to be a ZIF, and that stands for Zero Insertion Force. That means that the CPU should connect easily into the socket with no pressure or force involved during the installation. It just sort of drops right in there very easily. So no force because you don't want to damage any of the contacts here. There's two main types of sockets. There is PGA, which stands for Pin Grid Array. Pin Grid Array sockets accept CPUs that have pins covering the majority of the underside. And many AMD CPUs use PGA. And the other type is LGA, Land Grid Array. LGA sockets use LANs that protrude out and touch the CPU's contact points. LANs like these in this socket here. And many Intel CPUs use LGA, like this one we're showing. Here's an example of a installed CPU into that same socket. And this is an Intel CPU. That's a Core i7 that goes into this LGA 2011 socket. And so when you install this, you want to make sure that you place it in very gently. Again, it's zero insertion force in the socket. And you'll note a couple things here. First, you want to make sure that the orientation is correct. And you can see here we have pin 1 labeled. Pin 1 is the first pin or LAN in a CPU. And on this CPU, you see there's a little tiny triangle in the corner here that identifies pin 1. And if we look here, we'll see a little tiny triangle on the socket housing, which identifies pin 1. So you want to make sure that those match up and that you have this pin in the correct corner. That way you know that your CPU will be installed properly. After that, you want to place the lid over the CPU. And you can see here that the lid is open on the left picture here, and that the locking arm is in the up position. So we'd have to do a couple things here. First, we'd remove this plastic and then close the lid and then lock it down with this locking arm, which goes under this latch here. Then we'd apply some thermal paste or thermal compound, if you will, onto the CPU. And usually I'll do that horizontally here. Depends on your perspective, but I would do it in this direction. And then install the heatsink and fan assembly. For an in-depth install of this very CPU, see the appendix videos of this video course. And I go through an actual installation of this CPU and show exactly how to set it up, use the thermal paste, and install the heatsink and fan. And in fact, there's an entire computer build in the appendix section. So check that out. Once it's installed, you can look at your CPU in whatever operating system you're working in. So for example, if we go to Windows 10, we could access the device manager and we see processors here. And we see that this particular computer has a 4-core processor. You can also look over here in system information, which you can access with the msinfo32 command, and see what type of CPU is running in there. If you're using Linux, you could use something like the top program, And just type top in the terminal. To see the CPU information, we'll press the 1 key, and then we'll see all the CPU threads here. And these are listed from 0 through 11. So it's 12 threads altogether. It's a hex core or 6-core CPU. And what we're looking at here is the actual CPU I was just showing. But for this CPU to work properly and to disperse heat properly, it needs to be installed correctly. And so you want to make sure that you place your CPU into the socket in the appropriate way. Remember, 0 insertion force. And of course, make sure that it is compatible. You've got to use a CPU that is compatible with the socket. And you can check that at the motherboard documentation. So you'd want to go to the manufacturer of your motherboard, whoever that is, and make sure that the CPU you want to use is actually compatible and will fit in that socket, and that the BIOS UEFI will recognize it.